All right, I want to give you a little help on a couple of problems in the homework. Problem 56 is a limb with a weight of 151 newtons falls on a cable. It creates two angles, 14 newtons, and an unknown angle of theta. It also creates an unknown tension. The procedure is the same. We find the sum of the forces in the y direction, the two vertical components. The ups equal the down, the two vertical components equal the down force, and the left component equals the right component. But here's the thing: you'll have to remember this from when we did this in class. You're going to get a sine equation with sine in here, an equation cosine in here. Do you remember how we put the sine equation on the top and divide it by the cosine equation on the bottom? And we got tangent because sine over cosine is tangent. So I'll let you, there's my tip on that one there. Let me just go to the next problem. Here is a chandelier held by three cables. And you need to find the tension in, well, let's see, you need to find the tension in the cable. What makes this tricky is that, well, first of all, you're given a mass, and hopefully you remember in class that when you're given a mass, you've got to turn it into weight. Now, really, it's 9.8, but we're allowed to round it off to 10 and find easily that the chandelier weighs 440 newtons. Now, you're not given any angle at all, and we want the angle from the horizontal. But we know the opposite and the hypotenuse, so that's how I'm going to find the angle. Opposite 1.5, hypotenuse 2, and you can work out the theta right there. Now, I hope you recognize you actually only need Fy equals 0. The three ups, what are the three ups? The vertical component of each cable, all three vertical components equal the down force. The three ups equal the one down, which is the weight force. And so you need trig, and you got your theta, and that should do it. The three vertical components of the tension have to equal the 440 newtons. And that should pretty much do it, because the verticals are nothing more than t sine theta, aren't they? All these tensions are equal. Let's go back. Why are all the tensions equal? Because we're in a state of equilibrium and all these angles are equal. If the angles are equal, the tensions are equal in a state of equilibrium. And there's your few tips. Those are your two tips on two questions on the homework that you might have had some difficulty. Good luck.